What's up, everybody? This is a response to a question that we had in class yesterday, if this is today when you're watching it, but whenever you're seeing this one, and it's from question 4 out of our book, page 308. It said the function m of x equals 2x squared plus 6x minus 7 generates the same remainder for dividing x minus a, or also dividing x minus 2a when a is not 0. And so that's the key part that I'm going to show you right now. It's going to be like, oh, okay, remember that part. It says calculate the value or values, it could be multiple values of a, and determine the corresponding factors. And so I thought about it, I'm like, well, let's go ahead and just work through this one where we do the long division where x minus a is dividing our function. So I set all that up and I worked through this one in class and I left it because it was just burning on my mind. I did the whole compare the first term and the next thing in the list. And so when I multiplied 2x times x, that got an exact match for 2x squared. So that's always what I'm focused on, is what's the first term and what's matching. And then I did that to continue to multiply, distribute it out. So 2x times negative a gives me negative 2ax. Did the subtraction, drop down the negative 7, because that's how you do the long division. And then I looked at this term, 6x plus 2ax. And the only way that I can get that to happen is if up here in the numerator, this is not the numerator, this is the answer in the dividend, quotient, in the quotient, right? Words. 6 plus 2a has to multiply the x so that we can get 6x plus 2ax. And it matches what's up above it. But then you got to distribute, so 6 plus 2a times negative a, and that's going to give us this expression over here, the fact that your negative 7 and the negative 6a minus 2a squared is what you get from distributing 6 plus 2a times negative a. And then don't write anything. I thought this was a really interesting thing. These are the coefficients, the exact term from the original problem over here, that it had a 2x squared plus a 6x and minus a 7. And we see the exact same expression. We just switched the variables around. And that got me pause. In the moment in class, honestly, I was like, I need to think about it some more. I thought about it, I'm coming back to it, and you'll see how long the video is for how long it takes to actually explain how to do this question. Now, I went back to the problem and it said, what about x minus 2a? And so, we'll kind of get out of the way here. X minus 2a, I did the same thing. I still divided or multiplied the 2x up and put it up in a stack right here, because 2x times x is negative 2x squared. And then 2x times negative 2a, negative 4ax. Do the subtraction. These parts cancel, which is what we need. And then 6x minus negative 4ax means plus 4ax. I dropped the 7 down and I thought, okay, it might actually be better if instead of writing it as an expression where x is in both of those pieces, and up here x is by itself, what if I just factor? So this is kind of like a middle step that I'm not actually going to use, but I needed it because I got that point. So now I'm going to cover it up, and I'm going to realize that 6 plus 4a, that's a number. X is meant to be the variable, and we're trying to find the number, the coefficient of x. So until I know what a is going to be, and a is a number, I'm just going to treat it like a number and factor it out, factor out x. So I need 6 plus 4a to be multiplied by x to give me 6 plus 4a times x. It totally perfectly matches. You go back and you distribute it to the other one. So I did 6 plus 4a times negative 2a. And I wrote it like this. I wrote negative 2a times 6 plus 4a, and I just left it be that way. The first parts cancel. That's what we want. We want a 0 here. Negative 7 subtracted by negative, so I wrote a plus sign, 2a times, and I didn't distribute here like I did in this problem, although I probably should have, and you'll actually see that I do. I took the remainders, right? So I want to go back before I show that screen right there. You can kind of come back to it. This is the remainder. If we get a 0, then that means that that's a factor, but we don't get a 0 here. That would be an exercise to figure out, ooh, I love the extension, probably an extension in class. To get a 0 from that quadratic, you have to set that quadratic equal to 0 and solve it. Oh, and it's the quadratic formula. We did that part in class already. Okay, I'm in the moment thinking on the fly. Try not to make the video too much longer, but this is also the remainder for the other problem. So both of the answers here, there's nothing left to drop down from the dividend. So in that part, since we don't have a 0, this is the remainder of our division problem. So if I know that the question says make those remainders, when are those remainders equal for what values of a? Well, then I'm going to set the remainder from the first problem equal to the remainder of the second problem. And in doing that, that means I have a -7 on both sides, so cancel the -7. Bring everything down and realize that a 6a, because that was the remainder from that other question, and the plus 2a squared, well, that's on both sides. So we're going to combine, we're going to simplify, we're going to solve it. Eventually, I want to get a 0 over here. So by working my way through the problem, 0 equals what's left, which is 6a plus 6a squared. 6 in both spots, factor it out. A in both spots, factor it out, and you're left with 1 plus a. Haha, wetboards. You're left with 1 plus a as a factor all by itself, and then 6a over here. By the zero product property, either that equals 0 or that does. And if this equals 0, then a is 0, and we actually don't need to know about that because the original question said, zooming in over here, a can't be a 0. So leave that one alone. All right, now, that means the other factor has to equal 0. So if you set it equal to 0 and solve, we get the fact that a is -1. You think, oh, what do I do with that information, right? What do I do with that information? Well, the information said that we want we want the a value to be found. So if you put an a, getting ahead, I'm gonna go over this board. Told you, however long this video was, that's be how long, and longer for me to show it in class, so I figured a video is best. If I set a equal to 0, that's boring. We get x. And then both of them actually are gonna be the same divider because if a is 0 or if a is 0, that part goes away. And so we actually have the same expression. So we don't even really need to talk about when a equals 0 because it's what we call in math the trivial case. It's not really showing anything like new. No new ideas are popping out. But when a is -1, we get this for a divisor. Okay, cool. We get that for a divisor. If a, that was for the first part, right? X minus a. X minus 2a, when a is -1, gives us this for a divisor. So actually what we're saying in this problem, the answer to this question, and again, watch the video, pause the video, rewind the video, but there's more video to tell you, that if a equals -1, then x plus 1 and x plus 2 have the same remainder. Now, you can probably trust me because I have so much knowledge in mathematics and I've seen this question more than one time now. But we should probably prove it. Okay, that's where the video continues to grow. So let's go back and let's actually do the division. Let's take 2x squared plus 6x minus 7, and let's actually divide it by x plus 1. I've already done long division. Great process, love it. Long division was a necessary skill for this question, but let's do some synthetic division. Synthetic, SD, synthetic division. Now, the way that I know synthetic division is right or is gonna work for us is also practice, but I'm gonna see the same answer right there. That's the worst box I've ever drawn. We're gonna see the same answer in this space, and so that's the goal. You take the opposite of this, because if you look at this as a solution to x plus 1 equals 0, the solution, the root, goes right here. The coefficients, 2 and 6 and -7, we're gonna ignore the fact that they're coefficients of an x squared and an x and a constant. We're just gonna write down those coefficients here, and it's still the long division process. Long division has this zigzag stair-stepping like arrangement to it, but we're gonna let the synthetic division structure show us what this remainder is. Okay, here's the process. Drop down the 2, multiply 2 times -1, and that answer goes here, so zigzag. 2 times -1, -2. Add down the column. So a little add and a multiply, and then, I don't know, drop. Oh, we can even say, we could say add, right? 2 plus 0 is 2. Ooh, big brain move. Okay, so 6 minus 2 makes 4. Multiply. So that means -1 times 4. And now add down the column. -11. It turns out that when you divide 2x squared plus 6x minus 7 by x plus 1, we get a remainder of -11. And so the answer technically should be 2x because of the 2, plus 4, because of the 4, minus 11 over x plus 1. And this, specifically this, negative 11, that's the remainder when we divide by x plus 1. Let's now try to do the same problem with the other result. We had x minus 2a. When a is negative 1, that turns into x plus 2. So x plus 2 is going to divide our quadratic, 2x squared plus 6x minus 7. Okay, take the root, as in, what is x plus 2 equals 0? X equals negative 2. Put that out here. Take the coefficients, just like synthetic division from the other problem. Yep. And then let's go ahead and continue dividing. So I'm going to add, multiply, add, multiply, add. Oh my Lord, I get the exact same number here, negative 11, just like I got negative 11 over there. So that means when you do the long division process, if you do it synthetically or you do it the long division way, we're going to get 2x, because of the 2, 2x, plus 2, so plus 2, and never put anything over the x squared. And then this minus 11, that's the remainder. That's what we needed to get for this work to be proper. And it's going to be divided by x plus 2. Even though they are different results from dividing, they both produced a negative 11. That, ladies and gentlemen, and everyone else who is watching this video as well for entertainment or for knowledge purposes, that is how we know that for negative 4, the actual answer to, we can't even see the screen, let's zoom in. The actual answer, the values of a that actually produce the same remainders, there's only one of them, and it's negative 1. Thanks for watching all this video, skipping through it. You are the best, you're amazing. I will see you in the next video if more happen, and keep them questions coming. Well done.